Experiments are an integral component of physical sciences, such as chemistry. The most important part of the experiment is not doing the experiment, but rather interpreting your data, or trying to figure out what it says. That's the point of this video. I'm going to be talking about how do you analyze data, and how do you represent it, such as with graphs, and interpretation with precision versus accuracy, and how to calculate percent error. We're going to start first with graphs. Graphs are essentially the pictorial form of your data, and there are generally considered three broad categories of graphs. The first is a bar graph, which is simply just bars of data along the x-axis. And your data is essentially put into different categories. A circle graph, or otherwise known as a pie chart, is going to be a circle divided up into different sections based on your data. And finally, a line graph, it can either be points connected with lines, or it can be what we call scatter plot with a line of best fit. Line graphs are typically what you use in chemistry, so we're going to talk a little bit more in detail about that. First, for a line graph, you always need a title. If you're measuring, let's say, the length of someone's foot versus the length of their hand, your title would say something like length of extremities. On your y-axis, you should always have your dependent variable. All variables or all axes should have units. Your x-axis, which is the horizontal one, should have the independent variable. And again, you should have units. Now, as far as the data, often you will see it as scatter plot, as I mentioned beforehand, and you will have a line of best fit. Based on the slope of this line, you can tell the relationship between the two variables you're looking at. If you have a positive slope, we say that those two variables are directly proportional, meaning that when one goes up, the other goes up, or vice versa. When one goes down, the other goes down. On the other hand, if you have a negative slope, then we say they're indirectly proportional. When one goes up, the other one goes down. Now, once you get your data, you can often see it in charts, and you've got to figure out whether that data is good or not. So we look at precision versus accuracy. Precision is how close does your data, how close are your data points to one another. Accuracy is how close you are to the correct answer. So let's say that you took a block and measured it on 3 different balances. The data on the left here is your data. You have 5.73, 5.67, and 5.70. You get the data from another group. They have 5.78, 5.79, and 5.77. By looking at how closely each of these data points are together, we will say that the second group, or the other group on the right here, would be the most precise. Now, for accuracy, we need to know that the block should weigh 5.71. Looking at the two sets of data, we would say that your data would be the most accurate. Other than looking at the data points themselves, we can look at statistics. One thing we can look at is standard deviation. Standard deviation would tell you about the precision. The smaller the standard deviation, the more precise it is. Percent error tells you about the accuracy. Now, we're not worried about how to calculate standard deviation, but we will worry about how to do percent error. Percent error is going to be the accepted value, so in this case it's 5.71 minus the experimental. We take the average of your data, which would be 5.7, and we divide by 5.71, again the accepted, take the quotient of this and multiply by 100. Other thing to point out here are these bars on either end. These mean absolute value. That means that you would take the value of the number and ignore any signs. Thank you for watching, and this concludes this video.